Hello, and thank you for joining us for a special, shorter episode of the Podcast Aquatic, the official podcast of the Tennessee Aquarium. We like to call these quick chats the mic droplet episodes of the podcast. They're 10-minute or less discussions about a topic that just, tickles my fancy and that I think might be interesting to those of you who are listening out there in the podcast Aquanaut Core. And today I wanted to ask the question, how can we be sure that an animal is extinct? And to cover that topic, and by the way, the 10-minute timer has not yet started. I'll let you know when that starts. I thought I would return to old and well-plowed ground with Dr. Bernie Kahida, who is our aquatic conservation biologist at the Tennessee Aquarium Conservation Institute. Bernie, thanks for fielding this question and giving us a quick overview of what extinction is and how in the world we go about proving it.
No problem, Casey. This is a very interesting topic, and I'm happy to talk about it.
All right. Well, let me set our 10-minute timer, and So, Bernie, first of all, what is extinction?
People quite often misuse the term extinction. So extinction is a species is completely gone from the planet Earth. If a species is gone from a certain river system or from a state, but it's found elsewhere on the planet, it's extirpated from that state or from that watershed. Extinct refers to gone everywhere. So, and extirpated is a hard word to spell and say, so I understand why people use extinct instead of it, but I wish they'd learn this wonderful word, extirpated.
Yeah, so the longer version of that would be to say it's like is locally extinct.
Locally extinct.
Yeah, that's how I tend to use it. So and often we're talking about something like the lake sturgeon that was extirpated from the Tennessee River up until the 1970s.
Correct.
Okay. So why might scientists decide to declare a species to be extinct? What has to happen for them to cross over that threshold from being classified as maybe critically endangered to actually extinct?
So there are a lot of species that become so rare they're below detectable limits for scientists using the standard sampling techniques to look for them. This can be from the Cahaba pebble snail, which is a tiny little snail that lives on the underside of rocks, all the way up to the 3-foot-long Alabama sturgeon. The Cahaba pebble snail was declared extinct. It hadn't been seen in over 50 years. And then the Clean Water Act, it cleaned up the Cahaba River and the waste treatment plants in the greater Birmingham metropolitan area in the early 2000s, and a graduate student at the University of Alabama rediscovered the Cahaba pebble snail because they were small little individuals that were really rare with that poor water quality, and once the water quality got good, they exploded, and there's hundreds of thousands of them on some riffles now.
Oh, wow.
And right now, the Alabama sturgeon, one has not been captured since 2008.
Okay, so it's been almost 20 years, 17 years.
Almost 20 years. But something that lives in a big river that you are using gill nets or trot lines, and that's a long line with smaller lines off with hooks to catch big river fishes. You're just surveying such a small part of that river system. It's really easy to overlook. Now we've got this new technique, environmental DNA. And that's all the rage now. It's cutting edge. You filter water and you look for the genetic material that's sloughed off of a fish or in their waste products. But you don't know if that material is recent or it was in the sediment. And if it gets in the sediment and doesn't have any oxygen on it, it can be preserved for decades. And if you've got some dredging by the Corps of Engineers to keep a ship channel or something, it gets resuspended and you can get a positive hit. So the standard for freshwater fishes in North America, if you haven't seen them in 50 years and you've specifically looked for them, a lot of times they'll be declared extinct. But there's examples of things that have not been seen in over 50 years and they've been rediscovered.
Well, and there's we go into this in a lot greater detail, including what you just mentioned with the eDNA in the episode where we talk about your search for the Cirridaria shovel-nosed sturgeon in Central Asia. And that's part of the search for lost species, right? So that's a coordinated effort on the part of scientists all over the planet, including you, to go on quests looking for animals that, as you just mentioned, haven't been seen in a very long time, to find out one way or the other, are they around or are they not around? Although, as I think we're probably going to get into here in a second, you could go on lots and lots of expeditions and not see them, but does that prove that they're extinct? How can you, the crux of this conversation is it provable? So is extinction something that you can definitively say one way or the other, this animal is extinct, proven?
First of all, in science, you can't prove a negative, because you can look 1,000 times and not find anything, but the 1,001st time you might be able to find it. So all you can have is a well-supported hypothesis. And that's what science is. When you describe a new species, it's just a hypothesis. Someone can challenge that in another paper and say, no, it's not a distinct species. So we have well-supported hypotheses that certain species are extinct, but nothing can really be proven. Now, are woolly mammoths around? Probably not. That is probably about as close to a fact as you can get. But especially a lot of these small fishes, even if they're stream fishes that inhabit wadable streams, the tri-spot darter was thought it was extirpated from Alabama for 50 years. And then it was rediscovered, a very robust population, and a second population was found a couple years later. And they just had not looked, biologists, including myself, had not looked in the right habitat. But there's just so much we know about North American freshwater fishes, but so much we still don't know. And then you move to larger rivers, it gets much more extremely difficult to locate these species. Then you move to the ocean, like the coelacanth. It was thought extinct, and it was rediscovered in 1938 in a fish market. The larger the habitat, the more easy it is to overlook the animal, even if it's relatively large.
The Podcast Aquatic is made possible by support from the Tennessee Conservationist, the official magazine of Tennessee State Parks. This holiday season, give a gift that gets opened again and again. Printed sustainably, each issue of the Tennessee Conservationist is filled with fascinating stories about Tennessee's native species, rich history, and unique culture. Give a year subscription to your favorite outdoor enthusiast for just $20 at tnconservationist.org. I feel like you're probably, or actually we both are probably shaking a lot of people's reassurance that there are in fact no megalodons because scientists say that they are extinct, and now you're just telling them that, well, maybe they're extinct. That's the hypothesis. But the ocean's a pretty big place. Who's to say that there's not a megalodon? So how sure are we that megalodon is gone?
99.9999% probably.
What are we basing that on? Is it again just the fact that are scientists actually out there specifically looking for megalodon, or why can we be so certain about megalodon versus maybe another animal that we haven't seen in a long time?
First of all, that is a very large fish that got 50 feet long.
I don't know. They're big enough to scare me.
Yes, and they're predators. So everyone's seen the movies, right? Where the thermal climb kept them deep in the ocean. And you would have some big torn up things float ashore. I mean, there would be some evidence of a huge predator out there. And all the deep sea explorations we have done, you think one would pop up. But that's not to say one isn't lurking there somewhere. We can't prove it. We can just have a well-supported hypothesis.
All right. Well, my deep-seated and long-standing fear of there being megalodon in the ocean is, I guess, reignited. So thank you for that. So how do we feel then? There's a lot of news lately about advances in technology and in genetics research that suggests that we could, using some of these tissue samples, preserved tissue samples of things like the Tasmanian tiger or the woolly mammoth is a big one, obviously, about we could bring them back, we could de-extinct something. What is your thought about that as a scientist? And then I have a follow-up question to carry on to after that.
First of all, they're not really de-extincted, if that's a word, because you are just going to get a close relative. You're going to manipulate some of the genetics, and superficially it may look like the extinct animal, but it's not the extinct animal.
It's a hybridization.
It's a hybrid at best. But I think rather than trying to make Jurassic Park real at some superficial level and just gee-whizzing the public with what we can do with advanced genetics, it'd be wonderful if those resources could be put in conserving the species that are still extant, that are still around.
So instead of bringing back a woolly mammoth, maybe turn our attention and our resources to saving the African elephant, the Asian elephant.
Exactly. I mean, between habitat loss, pollution, poaching, climate change, all the things that both terrestrial, marine, and freshwater animals face, we need resources to try to mitigate all of those human-induced issues for life on the planet Earth. And just like we need to make the habitat on the planet better for humans and everything that lives there and not necessarily go to Mars, why don't we protect the animals we have, fight against more extinction, and not dream up something that looks good on CNN for a 5-minute clip but really doesn't make any difference?
Well, it does make people, I think it gets people excited because I think they like the feeling that science fiction could become science fact. And in that sense, I understand it, although I 100% agree with you that our resources could probably be better spent and devoted to the animals we still have around. Bernie, with that, unfortunately, our 10-minute timer is up. But if you want to know more about working to save extinct species or almost extinct species, we have many episodes about our work with the laurel dace, which came very, very close to extinction not just a year ago at the time of recording. And you can, I'll try and link those in the show notes if you want to check those out. Those are longer form episodes, not like this short mic droplet episode that is 10 minutes or less, hard out. So, Bernie, thank you so much for taking us on a little tour of what extinction is and what it means and the moral questions that are wrapped up in what extinction is and how we define it and how we fight it.
You are so welcome. And by the way, I have a very unique laurel dace shirt on today.
You do, in fact.
Celebrate that species that is on the brink of extinction.
If you have an idea for another episode of the podcast Aquatic, whether that's a full-length episode where we really dig into a topic and go for upwards of an hour, or one of these short mic droplet episodes that's, again, about 10 minutes or less, send that to me at podcast@tnaqua.org. While you're online, leave us a rating or write us a review. Those are both free and easy ways to support the show. And in the meantime, until next time, remember that every drop matters.